where we start to look at proportional relationships and how they look in and what they look like in graphs. So we have talked about what proportional relationships look like in tables. We've talked about what they look like when we can write equations for them. And today we're going to plot points based on the relationship between two different variables, and we are going to see what the graphs of proportional relationships look like. So this might be a bit of a review for you, and the review is going to be how we plot points on a coordinate grid. So I'm going to do the first point for you, and I want you guys to do the rest. So everyone's eyes up here, take a look at this. So the first one, we need to plot all of these points on this piece of graph paper they have for us. And just as a review, remember that this horizontal axis right here, this horizontal axis, we call that the x-axis. Okay, and this one up here, this vertical one, we call this the y-axis. Okay, and that's going to be helpful because when we go to plot coordinates from ordered pairs, like the first one, this is an ordered pair, 0, 10, an ordered pair. It's a pair of numbers that tells us where on the graph to place these points. So 0, 10, the first number is always our x value, and that tells us how far right or left to go on the x-axis. Whereas the second point is always our y value, and that tells us how far up or down to go on the y-axis, on the vertical axis. Okay, so for this first point, 0 is the value for x, and so I always start right here at 0, 0. This is called the origin. I always start at the origin, and if the x is 0, that means I don't go left or right at all. I just stay here in the middle. And then if the y value is 10, that means I go up to 10 on the vertical axis, on the y-axis, and I put a point. So everyone should have put a point right there. That's 0, 10. Now what I want you guys to do is to plot the rest of these points on this piece of graph paper, and then after you're done plotting all those points, I want you guys to answer this question. What do you notice about this graph? So I want you to come up with some characteristics of this graph after you've finished it. All right, ready, set, go. Yep, you have to answer the question. What do you notice about this graph?
Can I do a graph art? Graph art, oh.
No, we're just going to do mine today.
Well, are we going to this year?
No. 1, 8 means you go over 1 and up 8. And so you guys don't have to flip back and forth in your pages, in your book. You can just look at the ordered pairs on the screen up here, so you don't have to flip back and forth. I'll zoom in. Here are the points. On your own. And remember, after you plot the points, I want you guys to come up with some observations, characteristics for the points on this graph. Good. I don't have any band-aids. You have to go to the nurse.
Can I go?
Yeah. Okay, boom, there's one there. Quick, hustle up and get you going here. Okay, 2, 6, 2, 6.
Sorry.
4, or 3, 4. 3, 4. All right. So I'm going to go ahead and plot these points for us so we're all, and make sure your graph looks like what my graph looks like. So 1, 8 is going to be right here. 2, 6 is going to be right here. 3, 4 is going to be right here. And 4, 2 is going to be right here. So if I were to connect these dots with a line, it would look something like this. Okay, something like that. Now, what are some things that you notice about this graph? What's one thing you notice, Richter?
It's going down.
It's going down. Good. So we would say that this graph has a negative slope. And here's how we look at slope. When we look at slope, you always read a graph from left to right, just like you would read a book, okay? So if I'm reading this from left to right, okay, as I reveal the graph with the piece of paper, it's going down. Okay, again, it's going down. And a third time, ready? It's going down. So that would be a negative slope because it's going down as we look at it from left to right. Okay, Nora, what's something else you notice?
So you add the x-axis by 1 and you subtract the y-axis by 2.
Okay, yeah, so in other words, every single time I go to a point, the next point, I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And because I'm doing the exact same thing every time, that's what gives it this straight line, okay? So it's a straight line because I'm doing the exact same thing every time. I'm going down 2 from the y, over 1 for the x. Cloud, what do you notice?
Cubes, 144.
Okay, so there's a bunch of different squares on here, and that's what we use to make graphs. Good. Anything else you guys notice? Okay, there's one other thing I want to point out to you. When we look at graphs, it's oftentimes important to look at where the graph intersects the y-axis. Hey, Cloud. Cloud, thank you. Okay, so the other thing I want to point out right here is where the line intersects the y-axis, okay? So we call this the y-intercept. So the y-intercept for this graph is 10, meaning that when x is 0, y is equal to 10, okay? So that's really important as we move forward to look at where the y-intercept is, where that line intersects the y-axis. Okay, so moving on, next part. 10.2, now we're talking about a specific example here, t-shirts that are for sale. So everyone should be on this one. It says 10.2, and it has another piece of graph paper down below it. And now it says use the table to answer these questions. So it says some t-shirts cost $8 each. Some t-shirts cost $8 each. Now the first one, we have to figure out what does X and Y represent. So if I was going to label X and give it a label, don't say it out loud, but what would I give it? And if I were to label Y something, what would I label it? Talk to your table partners about what I should label X and Y. Ready, set, go.
So the x is t-shirt and y is yeah.
Okay, I want everyone to listen up. I want everyone to listen to Eden. Eden, what should I put for X? What does X represent in this situation? Yeah, so X represents the number of t-shirts, where Y represents what, Isis? Oh, she's right there. Okay, so Y represents what, Jocelyn?
Y on the cost.
Y is the cost, exactly, yeah. So the cost of t-shirts, so the total cost of t-shirts. I'm going to say total cost of t-shirts. Okay, so now we need to figure out, is there a proportional relationship between X and Y? So, one t-shirt costs $8, 2 t-shirts cost $16, 3 t-shirts cost $24, 4 t-shirts cost $32. So do you think this is a proportional relationship, Isis? Isis says she thinks it is, and I agree. So Junior, what do you think the constant of proportionality is? What are we doing to get from t-shirts to cost?
No, by 2.
No, because 1 times 2 is 2, not 8. So let's hear from Stice. What is the constant of proportionality here? Yeah, exactly. It's multiplying by 8 because for every t-shirt we multiply by 8 to figure out the total cost. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. 5 times 8 is 40. And 6 times 8 is 48. All right, so we would say, yes, this is a proportional relationship. So now that we know that this is a proportional relationship, we're going to plot these points for x and y into this graph, and that'll allow us to determine or to observe what a proportional relationship looks like in a graph form, okay? So I'm going to do the first point for you, and then I'll let you guys do the other one. So this first point, one t-shirt costs $8. Remember, number of t-shirts is our x-axis, okay? So we can put down here, instead of x, we can say number of t-shirts. All right, and then our y-axis, our vertical axis here, is going to be cost. So I'm just going to put a dollar sign there. All right, so one t-shirt, okay, so I go over 1 on the x-axis, costs $8. So I need to go up to where it represents 8 on the y-axis. Now every line represents $2. So this would be 2, 4, 6, 8. So I'm going to put a point right here. That point represents one t-shirt costing $8. All right, now I want you guys on your own to fill in the rest of these. So I've done 1, 8 for you guys. Now I want you guys to do the rest for 2 t-shirts, 3, 4, 5, and 6 t-shirts. Plot all those points and then connect the points with a line. And then after you're done with that, I want you guys to answer the question number 3. What do you notice about the graph that you just created? Okay, ready, set, go. On your own. Plot those points. Yeah, so if it's 2 and 16, you know, it would be, let me see if I can sort of put. So it would be 2, 4, 6, 8, 10, right? We're at 10, 12, 14, 16. Yeah, so you got it right. Okay, and then 3 would be 24, so we can go to 20. And then 2, 4, so that would be right there. Okay, again, once you're done with the graph, connect the dots with a line, and then write some things down about what you noticed about this graph. What's up? Well, it's 16. Look at this. Every one is worth 2. 2, 4, 6, 8, 10, 12, 14, 16 is right there. 3 and 24. So 3, go to 20, 22, and 24. There, right? Every little line going vertically is worth $2. Nice.
Do we have to connect the dots?
Yeah, connect the dots.
Do we start from 0?
Yes, dots. We're doing dots, not a line. So it should be one single dot right there, one single dot right there. What's up? What's your question, Angela?
I finished the graph, and it says on the homework, but how would you do 1 times 1.14?
Well, 1/4 is just 0.25, or 1/4 of a box.
So 0.25.
Yeah, so it'd just be, yeah, 1/4.
But the 90% is
Well, hold on.
0.25.
Hold on just a second. Okay, I need everyone's eyes up on the board in 3, 2, 1. All right, so everyone's graph should look something like this. All right, so when I connect all of these points with a straight line, and I'm going to extend it all the way through the y-axis, this is what it looks like. Okay, so what are some things that you notice about this graph? Olivia, what's one thing you notice about this graph?
That every time it like goes up, it goes up by like this side.
Okay, so what Olivia is noticing that it goes up by 1 on the x-axis, and then it goes up by $8 on the y-axis. Okay, so it goes over 1, up 8. 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 So, this is a very important characteristic of a proportional relationship when we graph it. So I'm going to keep track of this, and I'm going to make a list of 3 different things that proportional relationships always have when you graph them. Okay, so I want everyone to write these down too, because this is very important. Proportional relationships, Olivia just found the first thing that all proportional relationships have, and that is that they form a straight line. Okay, and I know it's a straight line because just like Olivia said, every single time I go over 1, up 8, over 1, up 8, over 1, up 8, over 1, up 8, and because I do the exact same thing every time, this forms a straight line. So that's the first thing we need to know. If you're trying to figure out whether or not a graph is a proportional relationship, you have to first look to see if it has a straight line. Straight line. If it doesn't have a straight line, it's not a proportional relationship. What's something else you notice, Nora?
Well, what you drew, it's kind of like a staircase.
It is kind of like a staircase, and staircases are just like this. If you go upstairs, the landing part of the stair, right, this part of the stair, is going to be the exact same size every time. And the vertical part of the stair, or how far up the stair is from the previous stair, is going to be the same every time as well. And so if you look at the relationship between height and width of a stair, it's going to be a proportional relationship. Yeah, Angela, what did you notice?
On the other scale, it was going down and it's going up.
Oh, that's really good. So Angela noticed that this has a positive slope. So again, we read graphs from left to right, and if I put a piece of paper over this and I reveal the line slowly, you can see it's going up. It's going up as I reveal it. Okay, so again, positive slope, it's going up. And a third time, positive slope as we read it from left to right. So that's the second characteristic. That's very good. So the second characteristic, all proportional relationships, when we graph them, all of the lines that are graphed have a positive slope. All of the proportional relationships are going to have a positive slope. Okay, what else do we notice about this graph? Any other observations you guys made? Emma, what did you notice?
I was going to say that it just goes up.
It goes up, so it has a positive slope. Yep, totally. Because that's completely different than the one we did first time. Remember the first graph we did? It went down, so that tells me this is not a proportional relationship. Okay, this one's going up, so it has to be. What else do you guys notice? Okay, let's hear from Brian. Check this out. Brian.
Yeah.
Remember when I talked about the y-intercept? What was it here? What number am I pointing to? 10. The y-intercept was 10 here. Brian, what is it here? 0. Okay, so this is the third thing that all proportional relationships have, and that thing is that they all go through the origin. Okay, they all go through the origin, or they all have I'll just say line goes through the origin. And the origin, again, is just the point 0, 0. Okay, and that should make sense because if we look back at the actual scenario, we're saying that one t-shirt costs $8. So if you go into the store and you buy 2 t-shirts, it costs $16. But if you go into that same store and Riley, you buy 0 t-shirts, how much is that going to cost? $0. So we could add a little row right here and say 0 t-shirts cost $0. And that's where I would get this point 0, 0 from. And all proportional relationships have 0, 0 as one of their ordered pairs. Okay? So these are the 3 things. All proportional relationships have to have a straight line, they have to have a positive slope, and the line has to go through 0, 0. All right? If they don't have one of these things, it's not a proportional relationship. All right. Now we're going to use that in this next activity. This next activity, I'm going to give you guys Everyone should have a set of cards on their table. But before you look at those cards, I want you to take everything else off of your table. So you should only have those cards on your table. I don't want to see pencils or books or binders or calculators or anything on your table. Only thing you should have on your table are those cards and those cards alone. Not even water bottles.